Hello guys, how you doing? I am so excited to finally have a chance to, to introduce you to this amazing derivative operators. And it's been in my timeline right now is 11:25. I should eat right now, but I'm going to do some video first and then, have lunch with my friend. So, today, well, you ask why I'm interested in this. Okay, why interest in derivative operator? Well, because aren't that you and some of your geek friends and some of your math professor were obsessed with a way to solve linear differential equation? It's really interesting, right? To solve linear differential, what do I mean linear? Linear, it means constant coefficient. Okay, like differential equation, if you guys are not familiar, is something like this. It's y prime plus 3y equal to 5x, something like this. Okay, and it's linear because you see the coefficient of each term of y is a number, so it's constant. Now, I'm pretty sure y'all heard about, let me try to list some of the methods, okay? That, you might heard of. You might heard your friends say, you might heard somewhere on YouTube, one day you get drunk and then YouTube take you so far and suddenly you learn how to solve differential equation. Who knows, right? But let's list some method you might heard of. We have variation of parameters, we have undetermined coefficient, and we have matrix diagonalization. Okay, I think this is the familiar methods y'all heard of. Okay, like so far, I mean, if you take a differential equation class, both as an engineering or a STEM major, you might heard of the tree method. So, but today I'm gonna introduce you the new one. I'm gonna introduce you the derivative operator way. Okay, of solving the differential equation. But I will be covering this paper. I will link it in the description below. But before we dive into this, let us explore. Okay, so let me call this I call this A1. Okay, property. Oh no, I'm not gonna call it A1. I'm gonna call it part A. Okay, property. So so like I say, differential equation, you remember, usually you see them written like this. Y prime prime. Okay, I'm not gonna do y prime prime. I'm gonna do like y4 minus 3y prime plus 2y prime plus y prime minus 10y equal e to the 4x. Like, for example, like that. Okay, now in the language of the of derivative operator, you write like this. So let's say, for example, okay, I will tell you some basic properties, and we're gonna write differential equation one in the language of derivative operator. Okay, so so I'm gonna assume for now. Okay. Y is a function of x. Okay, and because it wouldn't make any sense later if y is not a function of x. It can be a function of anything. It can be a function of t. It can be a function of z. But from now, for the sake of familiarity, we good human. We good with familiarity. So let's start it first. Let's start with something that we get used to. Okay, so when you write dy like this, it means that it means dy over dx, okay? Or the case y prime. I'm not going to use y prime in this presentation. I'm going to use dy over dx so that it makes more sense, because y prime, like, later you see it run into trouble, but you can use it as long as you understand it, okay? But in this presentation, I will use dy over dx, okay? So what does it mean? D brackets y, so it means that you have y, right? D is like, imagine D like a machine, okay? D is like a machine, you know? When you put y into this machine, what's gonna do? It's gonna take the derivative of y. You see what I'm saying? So d of y, it means that the machine gonna derive y, no, derivatively design y, or you know, imagine like you have a function y, you put into this machine, and this machine gonna take the derivative of it, and then later, you know, after 30 minutes, you come back and you say the machine will give you, okay, this is the derivative of y for you, okay? Now, there's some twist, okay? So how about this? What does it mean? Can anyone guess? Oh, sorry, I'm forgetting. I always forget that I'm live. So, I mean, I'm recording, not I'm live. So, but yeah. So at first, I look at it, I think it's dy over dx minus 5, right? Oh, my friend. You know, sometimes, unfortunately, this is not the correct answer. That's why I thought at first too, you know. But in fact, this is not the right answer. D minus 5 is the same. It's the bunch. It's a chunk. Okay, this is the chunk. It's not separated, and it has this chunk. Each component of this chunk. Okay, let me write in a very interesting way. You say, I would write like this, and no, not any component in this chunk will always have something to do with y. Okay, so what does it mean is, you know, you put y into the machine called d minus 5, right? And what is the machine gonna do? The machine, the first thing they're gonna do is they're gonna take the derivative of y, and then after that they're gonna minus 5 times y. Okay, so what does it mean? It means that, you know, mean that the machine will take the derivative of y and then minus 5, okay? And so in the normal language, it would be this. Okay. Yeah, so I think this the reason why you can do this is because of this is linear characteristic. So yeah, so our operator right here, the derivative operator, is linear. So if you recall linear, what does it mean? What makes a person linear? Oh, I'm sorry. What makes a operator linear? It means that, you know, when you take, let's say it's a function a and b, okay? What is the addition rule? They follow the addition rule. It means that you put, let's say you put your t-shirt and your pen into the machine, right? And then later you come back, you get result 1. You put your pant, and then you put your t-shirt in the machine. Okay, let me rephrase it. Sorry, forget what I say. Imagine like this. You put your pen and machine and you put your pen and t-shirt together into a machine, right? And later you come back, you say on the is dry. Okay, you put your pen first, and then you put your t-shirt inside the machine, and you come back, you see them both try. So I think that's what this mean. Okay, it means that, you know, whatever the order doesn't matter. Okay, you can do it together, or, you know, continuous, what's the word, continuously, but it should get the same result. Similarly, if you have a constant c, okay, it would be this. Okay, this is called the multiplicative. Let me make sure. Just want to make sure. Let me actually Google it for y'all. Characteristic. Let me additive, and multiplicate. There we are. Yeah, so this is called multiplicative properties. And this is called additive property. Okay, that's why like you can go from 1 here to 2. Okay, so let's do a final test and see anyone can tell me what's this. Say if you have d minus. Okay, actually let's do 2. Let's do 2 because we're gonna do linear. So okay. Okay, can anyone tell me this? What's this equal to? Can anyone tell me this? Number 2. Okay. Okay, I think you pause it. I think you have paused it and you try. Okay, so I'm gonna go ahead and give you answer. First you expand the first side. Okay, and then you do, because d squared y minus 2dy plus y, I guess. So it will become d squared y, it means derivative 2 times, okay, with respect to x. Like you take derivative of y 2 times, and you minus 2 times dy is popular, we talk about it. And when you take operator, you d of y, big D of y is dy over dx, okay? And then you just plus dy, okay? That's the answer for you. This one is d squared y plus 6dy. It would become exactly, this one is d, yeah, you take the y 2 times plus 6 times y over dx. Okay, so this is the language, the written language of d. Okay, and then we will explore, you know, the mathematical properties. Okay, so I'm gonna go to the paper, and then I'm gonna I will show you guys what does it mean. Okay, so the first properties I want to talk about right here, the first properties, okay? The first property I want to talk about is right, B, mathematical properties. Okay, the first mathematical properties I want to talk about is equation 1, section 2.1. Okay, so what does it mean? D minus A equal to E AX times D E negative AX. What does it mean? Okay, so you can look, there's explanation right there for you, but I just want to point out something. You see, they didn't write Y. You have to subtly understand it. They didn't write like this. Okay, they didn't write like this. Okay, they didn't include a Y because this apply for anything. It doesn't have to be a function Y. It can be function G, function H, function F, function U, as long as it's a function of X. Okay, so any function of X. So that's why they don't want to write it, because, you know, they want it to, you know, it's mathematician, you know, like they want to retain generalization. You know, they want to it apply to their own function. So they want to. It's cool too when you be generalized. You know, what is that? Write more about less. Right? Write less about more. Right? I don't know. I remember, you know, one of my engineering classes. You know, one of my professors taught me that. And this case is kind of useful. Okay. Now, let me ask you. So actually, let's talk about it. So, what does this term mean? This term mean that, you know, imagine this y here, okay? Should I write y or should I not write y? I mean, the research paper, they did not write y, but okay. This is for explanation. I'm gonna write y right here, okay? So that I can explain to you. Okay, now what is the left? I'll call it left. L for F, left. This is R for right. Okay. What is L equal to? L equal to D minus A. Y right. It will equal to dy minus AY equal to dy over dx minus y, right? You agree with me? All right. Let me see what's the right hand side equal to. Right hand side equal to this. Again, if you don't know what to do, just copy it. And I'm gonna write y right here so that it makes sense for y'all. Okay, so I'm gonna compute this one first. Okay, and then I time e to the power ax in. So so e to the power ax times. Okay, guys, be careful right here. At first, you know, is a lot of the first time I write like this. Okay, and this is not correct. It is not correct because, you know, it's not like you take the derivative of this and then you times y. No, you have to understand, like, it's like a machine. Okay, it's a machine and you put y in and gonna execute it via y. Okay, so the machine say that, okay, this I'm gonna take the derivative of whatever you give me. No. I'm gonna take the derivative with respect to x of whatever you okay, let me say it again. I'm sorry. Okay, so this machine right here, okay, d to the d of e negative ax basically say that, okay, I would take the derivative with respect to x of e to the power of negative ax times whatever you give me, whatever function you give me. In this case is y. Okay, that was it mean. It's not like at first I thought like you take the derivative of e to the power of negative ax and then you time y, but it's not correct. Okay, let's expand using the chain rule. Okay, and expand it to see what we get. So e to the power ax remain the same. Derivative of this one first is negative a times ax y. Okay, and then the derivative of y retain the first term. Okay, you times them together. It will be negative a times y plus dy over dx. Okay, equal to dy over dx minus ay. Okay, and yeah, I mean, oh god, I did a horrible mistake. This is not y, this is ay. Okay, be careful, guy. No, a is not there for messing. Okay. So yeah, we have the similar results right here and here. Okay, let me see what the time. Oh, it's 20 minutes already. Okay, I'm gonna stop. Yeah, but you see the point. The point is we have now we have two way of written it. This is a similar way. So the blue way, the yellow way. Yeah, it's similar. It's a similar thing. Okay. In the next video, we're gonna generalize it more. And then we will see what we can use with it. Thank you guys for your attention.